Yeah, g'day, Mark here, and welcome back to my channel. Now, if you watch videos from the likes of Lap Mountain Living, experts like Andy make tool grinding seem pretty easy. But especially when it comes to regrinding end mills, is it really that easy? Let's find out. My most used end mills are 10mm carbide, but I think I've managed to blunt in all of them. So these ones are all high-speed steel, which is nice, but I do like to have some carbide ones. But at the moment, they're all in the resharpening drawer. So let's just sort out my carbide 10mm cutters. May well be one, that's carbide. This is that. Yeah, that's carbide, it's a bit bigger. I think that is too. Right, I own 8 carbide 10mm cutters, and all of them are now blunt. They all have some form of chip out or damage, mostly to the tips, but also some of them have got a bit of damage to the flutes as well. So you can see the breakout on the tip on this one, and also chipping along the flutes. Well, that's got a huge chip out of there. I'll have to grind a fair bit off the tip of that, but it's got no real damage to the flutes, so that one's just a tip repair. Yeah, this was probably the best of all of them. It's really just got this minor damage on all 4 corners. The flutes won't need grinding on that one yet. This one also has substantial damage to the cutting flutes, so it's going to definitely need a flute regrind. And the tips also look pretty heavily worn and chipped out. Probably going to lose quite a bit of length before it cleans up as well. Okay, so I've got these 4 which need their flutes sharpened, and these 4 which just need the tips sharpened. Flutes and tips, but flutes first. For the resharpening, we've got basically 5 setups. Setup 1 is to do the flutes. Setup 2 is just to cut off any damage on the tip. Setup 3 gashes the tip between the cutting teeth for clearance. Setup 4 is to grind primary relief angles in the tip, and setup 5 secondary relief angles. Now when grinding the flutes, they also have both primary and secondary relief angles. So what do I mean by clearance angles? Any cutting tool is going to need to have a bit of clearance behind its cutting edge so that the tool doesn't rub. And regardless of whether that's cutting on the side with flutes like this, or whether you're cutting on the tip of the tool, either way you're going to need a primary relief angle, which is normally quite a small angle. These edges get weaker the more acute the angle between here and here becomes. But then you need some secondary clearance here to give space for the chips to not get jammed in. Now, different materials need different primary and secondary cutting angles, and also the type of cutter makes a difference. But seeing as I mainly cut mild steel, I'm looking for a 3-degree primary and a 6-degree secondary. Now, over the decades, a lot of very talented tool grinders and engineers have designed mechanisms to automate a lot of the tool grinding process. Now, at the very top end, you'll see machines like the Cincinnati Monoset, which I did a video on, the one that's owned by my mate Stefano in Chicago. Or another top-end mechanism would be the Haller tool grinding attachments. Now these sorts of things can give you all of the indexing of the number of teeth you need, and also can provide a controlled spiraling on those indexed teeth. But I don't have anything like that. The opposite end of the tool and cutter grinder pecking order is my Clarkson Mk1. This has no mechanisms for indexing or following flutes other than using fingers. So in this machine, all indexing's done with springy fingers. The tool's own flutes provide the alignment. And when grinding flutes, you use the same springy fingers in the flutes themselves to provide the guidance for the spirals. But you know, before I start grinding the carbide cutters, I think I might practice on some high-speed steel. Here's a nice big one that's got a huge chip cut out of it, so it's going to need to be shortened by nearly 10mm before I can start the regrind. So why don't I start with that? Now the Clarkson system doesn't use collets, but uses sleeves. And luckily I've got the perfect size sleeve for this cutter. These are all very precisely ground and very close fitting. So as such, they probably have less run out than most collet systems do. So we'll start off by doing the flutes of the worst damaged ones. Once we've touched up the flutes, we'll do the tips of all of them. So here's my flute grinding setup. It's a diamond wheel. It rotates down, so it's rotating into the cutting edge, so I shouldn't get breakout. I've got a finger here that's mounted rigidly. That picks up the flute, and that's the way I can index off from one flute to the next. Now ideally you'd have this tool holding shaft floating in an air bearing with almost no friction, but unfortunately I don't have that option. With this setup, I set the primary and secondary relief angles with the height of the wheel. So the first thing I need to do now is just touch off. So I'll just put some pen on the flutes so we can see better where they're grinding. One disadvantage of using flutes to guide the grinding is that you can never grind the entire length, because I need it to be not quite touching the wheel here, and then once I get to the end of the flute I'll run up against the run out of the flute before I grind it completely. Now carbide dust is not considered a health food, so in addition to vacuuming, it's mask on for this job. So this first grind is just a touch off to find what angle it's actually grinding. Well, that first cut was cutting the secondaries more than the primary, so we'll just raise the wheel up a bit more. Once I had my primary angle roughly set like this, I could adjust it slightly by shifting the finger left or right across the table, adjusting the engagement position. I'm checking now whether I have ground in some back clearance. The indicator should rise continually up to the cutting edge, which would indicate positive clearance. Now if the indicator was to go up and then come back down again before hitting the edge, that would mean it would rub. Okay, that looks okay. There is a bit of tooth to tooth variation in height though. With that setup, all of the other 4 flutes were done the same way. Okay, so here I've only cleaned up the primary angles. I'm probably getting a little bit too wide here, but I think I'll leave it at that. There you can compare it to an original. Because I've got a mix of 4 flute and 3 flute end mills to sharpen, and the 3 flutes have got different helix angles, I'm going to have to adjust the setup to grind those primaries as well. With their altered helix angles, I had to touch off again. Okay, that's just touching right on the leading edge. I need to drop this wheel down a whole bunch more. Getting towards the limit of what I can do without changing my setup completely. Still hitting that leading edge. Right, by moving the finger off to the side a bit and also changing its shape a little, I've managed to get a location that works. I've had to lower the wheel really low, so I'm cutting quite high up on it, but I think this is going to work. Okay, I'd say that seems pretty good for the flutes. I'd say that one's finished. Next one's also a 3 flute, very similar. Hopefully it'll work with the same setup. In the edit I noticed I didn't quite clean up the flute completely on this and there was still a chip in it. One of the issues I've got is just eyesight. I need reading glasses and this is pretty tough getting close enough and getting a good view on this stuff. Okay, now I've got all of the flutes reground. It's time to move on to all of them and start cutting away the damaged tips. Now, while I was earlier able to cut the tip off the high-speed steel end mill with a cut-off disc, here I need to rearrange everything so I can just grind away the tips of the carbide cutters. I don't have a thin carbide cut-off wheel. This end mill's about the worst of them. I think I need to grind back probably 6 millimeters or so before it'll clean up. And again with this operation I'm trying to leave a little pip sticking up in the middle of the end mill because that'll help alignment later. Now with all of the tips cleaned up, the next setup is to gash between the teeth to give clearance. I'll start with my high-speed steel cutter and a conventional grinding cup wheel. When it comes to restoring the tip of an end mill like this, one of the hardest parts I find is to do the gashing of the center correctly. But luckily there's a very good video from Andy at Lap Mountain Living. I'll leave a link. And so to use his method, what I need to do next is just grind in and rotate until I leave just a tiny little spot in the middle to align off. While Andy's got a fancy sort of a indexing head for his tool and cutter grinder, I have to make do with fingers. That's just the way it is with the Clarkson. I think I've got this set nicely vertical, so I'm ready to start gashing. Now looking at this tool's original grind, you can see that there were 2 teeth that were gashed to meet perfectly in the middle, and then 2 teeth that were relieved further back. I thought with center cutting you want 1 tooth to go across the middle. I'll try and do 1 tooth across the middle and 3 not. Well, I hope I gashed that right. So I should have this tooth being cutting to the center and then 3 teeth being more relieved. Not sure how even I got. Might have ground this one down a bit too far. Mail time. Well, the cup wheel was fine for high-speed steel. For the carbide gashing, I needed a nice thin diamond grinding wheel. Hopefully that should do the job. Another weakness of the Clarkson cutter grinder is that you don't have tapers to mount the grinding wheels on. They just go on a 1/2 inch shaft, so they never run perfectly true. Another aspect of the Clarkson, which gets a little bit annoying over time, is that nothing is easy to adjust. You have to do everything with spanners, Allen keys, and everything's a different size. And because it takes so much time to adjust everything between setups, it really does make sense to do a batch of like 8 milling cutters at a time. You can see here I had to do a couple of different starts. I had to move my grinding wheel over because initially I wasn't going through the center properly, through here. That's why I've got a bit wider gash than I would really want. This tooth is the one that's left to go all the way to the center to be the center cutting tooth, so that once I do the primary and secondary grind on them, you can see how the black colored tooth should go all the way to the center and the other 3 are relieved. So one thing I'm not really happy about is that this grinding wheel is just too wide here across the tip. So the best way I can think of to narrow that down a little honestly, that diamond wheel seemed pretty unimpressed by my efforts there. One thing I did just notice when I was grinding this one is that I saw little bits chipping off the corners here. And I think this problem is caused by the finger that I'm using to index the flutes being a bit too stiff. So it's putting too much pressure on that corner as it rolls over that edge. So what I'll do is duplicate this too stiff finger on an old piece of hacksaw blade, which is of course probably less than half the thickness. I like the length of this one, so that's why I want to duplicate it. So with regashing the ends now completed, the last operations are to do the primary and secondary relief angles on the cutting tips. Now to speed up the process, I'm using this finger holder here as a stop against the universal workhead. So this way I can go between parts relatively quickly. And I think this is probably roughly how they had it set up in the Clarkson factory when they used to manufacture end mills themselves. They would have had a line of machines set up, each one for a specific job. So you just quickly switch out the part, do the grinding, switch out the part, do the grinding, and the parts just moved along the production line from machine to machine. Right, with the flutes done and the gashing done, I then need a different setup to do the primary and secondary relief angles on the nose. So for that I'm going to swing the table back around to 90-degree position and switch to a cup wheel. The tip of an end mill is not perfectly perpendicular to its length. You'll have a slight dishing angle so that the tips cut and the middle doesn't rub. And that's normally a couple of degrees, so I need to set that next. Now we're back to a diamond grinding cup wheel for the carbide again. So with the 3-degree primary angle finished, next we angle up to 6 degrees for the secondaries. Well, I'm going to guess that that's probably a reasonably weak grind, especially this tooth here doesn't have a lot of meat on it. I've got a primary and a secondary relief angle everywhere. I probably should just touch up the corners with a stone. Because this is a roughing cutter with the sort of serrations in it, this corner here is especially very poorly supported. This one's better, that one's just a burr, and that one's just a burr. I just give those corners a very light stoning, because otherwise those little sort of pieces of serration are just going to fall off straight away. I think this one's the worst one. Right, I now have all 8 of them reground. So this is about the best of the heavily damaged ones. As you can see, I don't end up with a very nice parallel primary relief or primary grind. I've got sort of a radial shape to that. Not quite sure why. Hopefully someone will jump in and tell me what I'm doing wrong there. Now the worst one is this one, which by the time the tip cleaned up, I had removed most of the gashing. So that one needs gashing again. That's also the practice piece which I first started doing the gashing on. And since that one needs a setup for gashing again, it can go back in the resharpen box for next time. Now the worst thing you could do on a video like this would be to leave it there and say thanks for watching. But really, the only thing anyone's interested in is, does this work? So let's fire up the Maho and find out. Right, first up, we're going to try this one, which had the least damaged tip, but it got a side regrind. So what does this tell us about this first regrind? Well, the edge cut quite nicely. So my flute grinding looks like it's not too bad. Whereas the actual cut itself, it doesn't look that great. A lot of burrs being thrown up on the edges, so it's not cutting that cleanly on the corners, I'm guessing. There was just a 1mm depth of cut, but let's switch it out for a different end mill and see what the other ones look like. This next one's got original flutes, so it'll give us a good comparison of the surface finish on the side, but the tip was completely reground. Okay, with the same feed and speed, I got chatter on the edge this time, so that didn't like it as much as my regrind. Looking at the top, so in the middle I think I've got a bit of a divot. So obviously my gashing of the middle isn't complete. I'm leaving some spot in the middle higher than the corner, so that needs touching up. Looks like the center of the center cutting tooth is a little bit proud. Yeah, see that little curve up to the middle about there? That's causing it, I'd say. I'm going to guess that issue's caused by the corner radius here on my grinding wheel. To fix that, I'd have to somehow dress this grinding wheel to take that little bit of curvature off the edge. And given that that's caused by just this one tiny feature on one tooth, I wonder if it's possible to simply dress it off with a diamond file. Well, it's still a bit proud. Let's try plan B. Let's try just grinding away that bit with a diamond burr. Well, playing around with the crappy diamond burrs didn't fix the problem, so I still need to clear out the center of that more effectively. Let's try one of the 3 flute mills with reground flutes. Okay, well, while the fireworks look kind of cool, the massive overheating here and all the spark, and also everything really. So I'm going to say this was not a well-ground tool. So is it easy to regrind end mills? Well, frankly, no. Just watching a few YouTube videos to try and copy the way that the experts do it, well, why would it be easy? Tool grinding is a trade. People used to do a whole apprenticeship over multiple years to learn this trade, and it turns out there's a zillion little variables. So tool grinding on a machine like this is kind of harder than it looks. Some of the things that make it difficult are when you're putting the tool in against a finger, you only need a small difference in the axial position to make a rather significant change to the rotational positioning of the cutting edges, and therefore to the clearance and rake angles. When you're only trying to set a 3-degree rake angle, that's only a very small change in the position to screw that up. Even small details like the wear and shape and radius of the corners of your grinding wheels can kind of have an oversized effect. All of this together makes it pretty hard to nail a perfectly ground end mill, especially a small one. Obviously, the larger the part you're grinding, the easier it becomes because the errors become relatively smaller. I definitely understand why industries basically, for the large part, stopped regrinding in-house. And if they do any regrinds, they send stuff out for professionals to do it. It's also clear that it's very much a practice thing. And I don't have much practice at it yet, but at the rate that I manage to blunt in tools, I'm sure I'll get some practice. So it turns out that regrinding end mills in the home shop is rather inefficient. It really takes quite a lot of time to set up, especially if you've got differences like 3 flute and 4 flute. However, with the price of carbide, and especially with sizes above 10 millimeters, I think it does pay to resharpen them. And therefore, it makes sense to wait till you've collected up a large number and do them all in one go. Thanks a lot for watching.